Welcome, everyone. Let's dive straight into what is, without a doubt, the most critical corporate rivalry on the planet today. We're talking about the heavyweight title fight between Taiwan's semiconductor manufacturing company, better known as TSMC, and Samsung. This is the battle that quite literally powers your entire digital life, from the phone in your pocket to the massive AI servers running in the cloud.
Now, just to wrap our heads around the sheer stakes of this fight, let's look at a truly mind-boggling number: $28 billion. According to industry estimates, that is the price tag to build just one single cutting-edge 2-nanometer fabrication plant today. I mean, that's up from about $20 billion for the previous generation. It's a staggering barrier to entry, and it proves this is a game played exclusively by absolute giants using the most complex manufacturing tools in human history.
And yet this rivalry isn't just about padding corporate profits anymore. It's really about the very basis of global influence. These tiny little chips are the engines driving the artificial intelligence revolution and powering advanced military systems. Like this quote perfectly highlights, semiconductors have shifted from being simple factory goods and have literally become the main tool in the contest for world power.
So, let's get into round one, the global chip war.
You've probably heard the term silicon shield thrown around. Well, TSMC is the undisputed champion operating right behind the shield in Taiwan. By manufacturing around 90% of the global supply of the most advanced computer chips, they've made themselves practically irreplaceable. The entire global tech ecosystem depends on this wildly complex, multi-continent semiconductor supply chain funneling right through Taiwan. And that gives the island some incredible strategic leverage.
But the intense geopolitical pressure to secure these supply chains is actually forcing TSMC to expand its physical footprint. Governments everywhere want chips made on their own soil, so TSMC is out there building fabs in places like Arizona, Japan, and Dresden, Germany. And they're doing all of this despite massive costs, crazy bureaucratic challenges, and needing to rely on hefty government subsidies, all to kind of de-risk that silicon shield.
Okay, moving on to round two, tail of the tape. Let's compare the fundamentally different business models of our two competitors. The absolute crucial point here is trust. TSMC operates on what's called a pure-play foundry model. They never design their own products. They strictly manufacture the designs they're handed. Samsung, on the other hand, comes from an integrated device manufacturer, or IDM, background. So Samsung's foundry division is in this incredibly tricky spot, where they have to somehow convince clients to hand over their highly secretive chip designs to a company that also makes competing smartphones and electronics.
Because of that pure-play neutrality, TSMC has locked in the absolute biggest names in tech. We're talking Apple, NVIDIA, AMD, Broadcom, Qualcomm. They all rely on TSMC. This pure-play model ensures that an Apple or an NVIDIA doesn't have to worry that TSMC is going to steal their chip design to make a competing product. That level of trust secures overwhelming, guaranteed demand for TSMC's advanced nodes.
This brings us to round three, the market share divide.
This is where we see the Goliath truly towering over David in their intense market share rivalry. Just look at this sheer dominance from the late 2025 data. TSMC holds a massive 71% market share compared to Samsung's 7.3%. It creates an immediate, striking contrast in their current market power. I mean, sure, Samsung is a total giant in memory chips and consumer electronics, but in the pure foundry business, TSMC is practically a monopoly at the leading edge. And because TSMC commands that 71% market share, they also command some truly incredible pricing power. Industry estimates suggest a single 2-nanometer wafer could cost clients a staggering $30,000. That is a 50% jump from the previous 3-nanometer generation. But clients are paying it. The performance gains for AI are just that essential. And frankly, they have almost nowhere else to go for this level of reliable manufacturing.
But hey, a fight isn't won on past victories alone. Welcome to round four, racing to 2 nanometers quad level. Let's jump right into the bleeding-edge technology node competition. This timeline perfectly maps out the frantic, escalating pace of innovation. Notice how both of these giants officially initiated 2-nanometer production right at the very end of 2025. TSMC announced mass production in Q4, while Samsung launched their Exynos 2600 chip at 2 nanometers in December. So on paper, it looks like an absolute dead heat.
But the strategies behind these timelines? Totally different. Samsung took an early, super risky leap into a highly complex new transistor architecture called Gate-All-Around, or GAA, back at their 3-nanometer node.
and it caused them massive yield headaches. They really struggled to produce these microscopic 3D structures without defects. TSMC, though, they were methodical. They waited until 2 nanometers to actually deploy GAA, sticking with older, proven tech for 3M. That methodical approach ensured stability, which is exactly why giants like Apple booked over half of TSMC's initial 2-nanometer capacity right out of the gate.
However, just when you might count Samsung out, they fight back. They've introduced breakthrough thermal technologies like hot path blocking to fix those previous overheating issues in their own chips. They've reportedly stabilized their 2-nanometer yields to a much more competitive 50 to 60%. And crucially, they're using these improvements to aggressively court massive clients like AMD and potentially even Qualcomm, actively trying to pry away TSMC's most loyal partners.
This brilliantly illustrates the ultimate core of semiconductor physics and economics. Yield is king. The real test isn't just making a single 2nm chip in a lab, it's manufacturing millions of them consistently without any defects. Ultimately, whoever achieves the highest production yield at 2 nanometers is going to take the crown, attract the biggest clients, and rake in the profits needed to fund the next generation.
Let's step into our final round. Round 5. Future of the Silicon Shield.
What does this rivalry mean for the future of global technology and politics? Well, we're entering an era where companies like TSMC and Samsung are no longer just traditional businesses. These firms are acting as quasi-sovereign entities. They're deeply embedded in institutional politics, absorbing massive geopolitical risks, navigating complex alliances between global superpowers, and pushing the very boundaries of artificial intelligence. Their corporate decisions are quite literally shaping national security strategies all around the globe.
With both companies already drawing up battle plans for 2029 and beyond, looking towards 1.4 nanometer and eventually 1 nanometer processes, we have to ask, as the limits of physics close in, who will win the ultimate, high-stakes sprint? Will TSMC maintain its absolute staggering dominance in market share, or will Samsung's aggressive technological gambles finally pay off? The entire AI revolution depends on the answer. Thanks for joining me on this explainer, and keep your eyes on the silicon.